welcome to second to last, third to last session. How's everyone doing? How's the rainy NDC day going so far? Good, yeah. It's welcome to maybe the only session that doesn't have AI in the title, so you found I guess the right room if you're there for that. So this is really meant to be a ranty session. This is meant to be a session that can be interactive, should you so choose so. This is also really all about kind of building that kind on top of war stories, if we can call them that. It's really opinionated. It's really fun session to do. It's really fun when we have some call-outs from the audience as well. So please don't kind of hesitate to ask any questions. Throw me some tangents. I'm happy to kind of take a curveball here and there and kind of add some additional context, skip over some stuff, and yeah, let's have some fun with all that. So this is really a session about cloud misconfigurations. Yes, we can tie that into AI if that gets you kind of credit at work, but it's really focused on the cloud bits and pieces of that. So with that, let's get started. All right, and the clicker works. Hi everyone, my name is Karl. I'm a cloud security consultant. I'm based in New York City. I'm working on my day job as an enterprise consultant, so working with mostly kind of Fortune 500 companies all around the world. Mostly, of course, companies that buy security consultants, so like regulated areas, etc. But I do also like to work with kind of small product folks, startups, scale-ups, etc. as well. So some of the jargon may be kind of enterprisey there, but don't worry, I'm happy to kind of keep that more kind of practical, pragmatic as well. After all, we're all engineers one way or another here. I'm a Microsoft RD as well as an MVP as well, but I'm trying to keep most of the language here agnostic to whichever cloud we are using. I do know that a lot of folks here are also from that Microsoft world, but not exclusively. So whenever I'm using a term that is kind of overloaded in another technology, just call me out on that, and happy to translate all of that for you. All right, so let's get started with the main session here. So let's first off look at a little bit of what are the main reasons for these cloud data breaches. We've been doing this cloud thing for a while, depending on the definition, depending on what we actually call cloud security part of the cloud. 10, 15 years at the very least. And one thing has been quite consistent from the very beginning. And let's look at this maybe from like 10 years ago. What was the number one thing? The moment they defined in the threat reports the term misconfiguration, it immediately jumped into the top list of the biggest reason to why were the attackers able to get in. Almost like an overloaded term, just like we have various levels of different types of prompt injections nowadays. Misconfigurations was this kind of overarching term that we kind of labeled or attributed most of these attacks that were cloud originated. And the same thing was also true 5 years ago or so. We started to see some tooling in there. We saw CNAPP, the Cloud Native Application Protection Platform, kind of being introduced as a term in there, and still misconfigurations being there at the very top of our cloud list. Of course, nowadays with AI, everything changes. It's all 0 days and all that sort of stuff. No, it's still misconfigurations. So it's time and time again. It's the stuff that we should know how to fix. It's not the fancy 0 days. It's not the new AI-powered attack that is somehow self-evolving or anything like that. It's still the misconfigurations by far. So let's do a short definition of that in here. So basically, a cloud misconfiguration is any configuration defect that either you leave a unsecure default on. If you've used cloud services before, you know that usually you either have to pay extra for that for the security to be there, or you have to pay your SSO tax, or you have to actually go ahead and change those default configurations in there. So it may be just that you tick a box and you change that default setting that's in there. Or it may be something that you have everything in green, it looks good on an individual service level, but when you actually combine that together with maybe your database, your key vault, and maybe something on the compute layer, if you actually put these things together, even though if they're individually properly configured, the actual cumulative effect is not great for you. And that's where this kind of terminology of cloud attack paths and this kind of different types of graphs to illustrate the attack vectors really come in as well. How do we actually combine these different levels of controls within the cloud? So with that, we can kind of start looking at just a couple of examples of those, just so that we are all on the same page in here. Again, it's not just like ticking a box. It's not a particular default change. It's not a particular one single thing, and it keeps on evolving, of course. Kind of a classic one maybe here is that you are using a storage account or a storage bucket in your cloud service that is using a legacy kind of key-based authentication. There's a single connection string, single key that anyone can use to actually log into this bucket. That's something that we, again, individually we know that we shouldn't be doing this. Again, as a consultant, when I review any of the findings with my customers, time and time again, there's always an excuse. Oh, this is just these are just storage accounts for something legacy, or this is just something that we use for, I don't know, performance logs. There shouldn't be. We know that there isn't any sensitive in there because we decided so. And that this sort of argumentation there. This is all again something that needs to be consistently enforced. But another example here is kind of building on top of that. You are using this storage account or a storage bucket somewhere. It can be easily accessed by anyone. It can be even anonymously accessed, and it can be even accessed publicly behind any network as well. Or you may have the same thing even if you are a big car manufacturer, even if you pride yourself of being a software-defined car manufacturer, you're still going to get eventually caught out with this, exposing your Kubernetes dashboards to the public. Like, again, things that aren't even there on default, that dashboard isn't there even by default anymore. But if you are really want to do something quick and dirty, that's the hole that you're going to end up poking yourself. Sometimes these are intentional as well. And then maybe just last example, another type of storage, another item that I see quite often, a set of container registries that are just publicly enabled for pool, just for easy access, just because they maybe have felt that it's hard to define a kind of allowed network access list for those pools, and it's somehow the moment it leaves the CI/CD, the container events seems to be no longer considered as sensitive as it was previously. Mind blowing. But these are just some individual types of misconfigurations. There's plenty of others, but just to give you an understanding of what do I mean when I talk about misconfigurations. So let's get a little bit more introduction on the different ways how I see these kind of horsemen of misconfiguration apocalypse or cloud apocalypse actually happening in the real world. So there's a small cast of characters, these four horsemen that I'm going to use to kind of, the analogy will kill itself quite soon, but I'm going to use to try to illustrate these kind of patterns of misconfigurations instead of going through those individual services one by one and line by line talking about why this is wrong. Let's kind of look at this from a kind of slightly kind of higher level, mindset level perspective. These are basically four levels of, these are not anti-patterns, but these are like categories of misconfigurations, so to say, that really account for majority, like 3/4 of the stuff that I see. I typically can tie back into this here. So again, these are not bugs. These are not something that someone's left something there unintentionally. This is really something that we are kind of approaching the entire cloud implementation there wrong. So let's start looking at this. So the first one, I kind of cheating here a little bit. It's kind of this legacy mindset. This is kind of there may be kind of a whiff of this through multiple different angles, but this is kind of using an existing set of tools that you had, using the existing set of controls, the existing mindset, and bringing that from the on-premises world to the cloud. It may be I had this shiny object from the network controls layer. This is the firewall, or this is the very fancy tool that I've used to using. I have to be able to use that there because it's expensive, because it's currently so much of my budget. It has to be there on the cloud world as well. Otherwise, we haven't invested into this cloud security thing. Some of my enterprise clients really are tied, their budgets are tied to the tools as well. So even if they would know or want to actually go ahead and fix those, they need to be able to tie the actual fixing of the work into some sort of a tool so that they can actually get paid the next year for these tools as well. But this is really about bringing this kind of legacy security mindset into the cloud, not kind of changing things. If you are kind of specific on like Azure world, for example, and this translates very differently in different clouds, you may have very strict network configuration, very strict processes on reviewing those network changes, but at the same time you may be giving subscription level or management group level permissions to your developers. So it doesn't matter how your NSG has been configured, the devs can actually just, first of all, spin up their own NSG, or they can just go ahead and override those changes anyway. So kind of not understanding the kind of nation or the difference between control and data planes and how do these work actually together. What's the level of hierarchy that is higher than the network instance that I'm deploying on the Azure world, or the set of configurations that I would do in GCP. And this is, again, because this is more of a mindset one, this is more of a philosophical one that we need to change. It's a lot of these things that we as devs may already know, but getting these kind of change on that implementation counterpart perspective may require quite a bit of work there. So first of all, cloud workloads ephemeral, whether we are talking about functions as a service, containers, or just plain virtual machines, they are just multitudes of levels of closer to that ephemeral nature that we had. It's not that you just forget something and it's hidden somewhere in an office no one ever goes to. We can find those workloads. We should be able to tap into the logs of those workloads when they appear. It's not that there's no one looking at these things. So I mentioned those network-based kind of traditional rules that you would quite often end up setting. Of course, when we are dealing with massive amounts of functions as a service, when the actual services themselves won't exist yet, or if you are dealing with very fast-moving like a Kubernetes environment or other environments where we have a very kind of short lifespan of these ephemeral services, tying this into some sort of a workload identity or some sort of a quick certificate-based identity provider is really crucial. Now that we have also on the AWS side similar concepts for workload identities, we really don't have any excuses. We can go very manual, we can do stuff like SPIFFE, or we can go and use the cloud native ones. I don't kind of truly mind as long as those rules are tied to the identities themselves, not to those kind of traditionally permanent network rules there. Hopefully preaching to the choir here, but you never know. And then last one, of course, if you are dealing with those Kubernetes environments, if you are doing this kind of cloud native world, then introducing a service mesh of your choice. There seems to be a lot of consolidation there on the market there right now, but certainly having this approach that the entire network itself is also ephemeral. It's not just my existing cluster and this is that I predefine and I've gone through my internal architectural review and these are the network addresses that I'm ever going to have and these are those services. No, it needs to be dynamic and needs to be something that is, whether you're doing something like namespace-based or label-based or choose your own adventure in terms of granularity, as long as it's not this kind of traditional individual network that we kind of just this is it, and there's no other networks in there, because of course in the cloud a network is just another resource that we can create. So the next character is this over-provisioning of these permissions, this kind of sprawl of super admin type of credentials. It's basically the stuff that if you ever needed to do something very quick and you weren't able to do it, you go and ask for the next level of access, or you go and get provision for the next set of pre-approved permissions. And once you get that access, it's gonna quite often stay there. Or if you are wanting to do the right thing, if you have this kind of architectural committee or this kind of traditional ivory tower kind of pre-approval type of approach that you define very granularly upfront, that these are the permissions that I'm gonna need, well, the cloud changes, your own needs change. Even if you don't make any changes to your application anymore, the actual APIs on the cloud side change as well. You may get grandfathered into something that now has completely different set of permissions in there. And also the same is true also with that just amount of those workload identities that we are having there. If you are moving away from this kind of token and key-based access, then having this, whether we have service principals or just custom SSH key pairs or whatever the set of non-human identities that we have, those are the ones that are going to get unused. Those are the ones that when someone comes knocking, they are going to be able to find out and reuse or repurpose for something that you never really intended. So really two things, the kind of over-permissive users, human identities, and then kind of this unused non-human identities, whether or not they are appropriate for that level of permissions. So how do we fix these things? Well, there are still, just like on the storage side that we talked about on the example misconfiguration, there's still plenty of services that are not automatically tied into a central IDP, whether it is built into your existing cloud provider, or it is something that you will bring your own. You have your own Auth0 that you always use. Basically, just the capability of OIDC connector for this cloud service that is quite often either not there or wasn't there when the dev team or the application actually started building this out. So moving away from that kind of previous, usually even kind of not even complementary, but kind of competing identity system that we used to have in these tools is more of a migration question. But we really do need to move away from those. We need to disable both the key-based legacy authentications and the non-standards, not centrally managed IDPs. There's this anti-pattern that you are using like almost like a separate identity tenant for each of your application because it's easier. You will have your own access in Azure terms. You have global admins, so you can create your own service principals. It's great. As a dev, I can do all the things. I can register to apps, but that also means that there's just so much more of the previous problem space that we just introduced as well. Now, use a central IDP. I don't really care which one, as long as it is something that you actually have that team, the process in place that makes sense. Make sure that joiners, movers, leavers are actually accounted for. There's maybe even a tool that you can introduce to actually check whether or not these permissions are needed anymore. Role-based access control, attribution-based access control. Depends a lot on your level of problem space. Are you working on a single application? Do you need to solve this at scale for folks who may not even know the cloud controls at all? Depends. So that part depends on the level of expertise in there. But what you can introduce, as I mentioned, this tooling perspective, you can introduce this identity as code, or there's some analyst jargon on this space, which is kind of KEAM, which stands for Cloud Infrastructure and Entitlement Management, which has nothing to do with infrastructure, but because of how Gartners and others work, That's the term that's being used. That's what you have in tools like checkmarks. You have tools like Viz, I believe, also has a key provider. Entra Permissions Management used to be this tool. Now it's getting integrated into Defender for Cloud as well. What these actually do, all of them, is I just have an example of kind of a manual tool, non kind of commercial tool in here. It's a bit of an older project, Air IAM. And this is basically what it does. It just you log into your AWS account, you just export all of your existing role assignments, and you compare those to the logs of activities of those role assignments. So basically, what it's here I have a couple of, depends on how visible it is for you all here there, but I'm just calling out there a couple of things. There is a user called booth admin that is there, and 192 days ago last used user, certainly something that we should be able to reduce. And at the same time, we have these other users that are like for like specific use cases based on name, like some sort of Lambda related role that has never been used. So again, you maybe click through yourself on some sort of a getting started wizard, actually went through the steps of creating those identities or maybe provisioned something, but ended up not doing these things at all. Again, this is stuff that is, whether you have a tool, whether you have a process, whether you have a set of responsibilities for your existing team, these are the activities that you need to be doing more and more often and at scale on your cloud credential perspective. There's commercial tools, there you can do this yourself. This is also great example of just use a machine to do this. Just either buy that commercial tool or just script it yourself, build an agent or whatever we call this nowadays, and just make them do this job of scanning of activities and activities versus permissions actually granted. The commercial tools, basically what they do is that they make sure that all of the logs are instrumented. They listen to those for like 30, 60, 90 days, and then they start giving you guidance of like what's in here. For example, here's a Terraform role-based access control list, or here's a Terraform template that you can use to deploy this exactly the same set of identity and permissions infrastructure. If you do this, you can actually keep this in your Terraform state. Any changes actually will need to then later go through this TF state as well. So you can use that as an enforcement part as well, not just for monitoring. And then you can also do this, what those commercial tools are doing, basically this guidance of what is the least permissive custom role that could actually work and still let you do the things that you are really doing in your day-to-day life. Again, something that, like in Azure, there's like 1,200 different built-in roles, and custom roles are then on top of that. There's just way too much for you if you have a broader team that you need to manage for those role perspective. So, Keem, and then similar other tools that you can use to build for broader space, this kind of identity and access, cloud identity and access as code. And then I do have another one on access control, kind of IAM similar one as well. This is where we kind of break this kind of double click on that central IDP. So I move slightly quicker on this one. This is basically where we break this kind of data plane access control, where we have good granular set of controls. Maybe we have a Keem deployed, we have a good set of hygiene. Only central IT team is able to provision some of those permissions in there. They're the only ones who can make those changes. But then we are still in parallel using some of these other kind of legacy tooling in our data plane access control as well. So just quickly going through those examples, you may have that storage account access key that is used for a valid reason. If you have a valid reason for that, you need to have a way of kind of disconnecting yourself from that problem space. Rather than using it directly, put it in a key vault, use that key vault, with those central IDP and do all of your normal hygiene in there. If you have access to those data plane roles, use those rather than those legacy roles that are outside of the central management in there. And then we talk about storage accounts. You should enforce those with policies. At its simplest, it's really as simple as allow stupid stuff, yes or no, and then you just need to follow, make sure that you read, is the configuration there asked in a negative or a straightforward way there. And then on the fourth category of this, this is, again, I mentioned earlier, one of these things that I wish I wasn't here again talking about these exactly the same things. We mostly know that you shouldn't put any publicly available stuff in the cloud. We know that this is kind of the anti-pattern or the kind of anti-thesis of what we should be doing in here. But again, time and time again, this is the stuff that I keep on seeing. This is the stuff that when you don't even need to do a pen test to do this, to find something obscure somewhere. This is, again, sometimes even intentional in some cases in there, just for a little while. But again, the reality is that if you have anything just for a little while on the cloud and publicly available, it's immediately going to get scanned. It's immediately going to get exposed. Here is, not sure, oh, it is, at least here, 2 feet from the screen, it is readable. Hopefully they're on the back as well. But this is basically a container instance, Azure container instance application that's up for just a couple of hours to get a little bit of more logs. Well, first of all, the initial first scan happens in like less than a minute. And then you start to see there's some kind of some application-specific scanning. There's some fake API calls. There's like get/API payloads in there. There is some interesting user agents happening. Basically, all sorts of things. Application level scanning, network port scanning. Doesn't matter what you have in the cloud. Doesn't matter if it's kind of separate cloud environment that's considered test or sandbox. If it somehow is related to your brand, or if it is related to kind of that company that you're working for, this is kind of your least common denominator here. You need to be able to avoid this altogether. And unfortunately, it is specific to each of these services. It's not like you have a one box or one check mark in the entire Google project or AWS account organization or Azure management group where you just say don't allow any public network. You do need to go through each and every one of those services to make sure that it's configured. You get to that not publicly exposed state, and you actually stay on that state as well. And that's what requires some of the stuff that we just talked about on the policy side. It requires some of those settings that we talked about. And it requires also a little bit of that evergreen shifting left as well. And now we are shifting a little bit to talk about how do we fix these things. So I mentioned a few of these different levels where we can fix to enforce these security defaults. We know kind of what can we do, but there's various different tooling, there's various different approaches that we can take here to make sure that it's not just the one-time exercise for us. It's something that actually then stays on that known good level of configuration as well. So I'm going to talk a little bit about secure defaults. I'm going to talk about how to integrate this with your existing security processes, and then I'm going to take 5 minutes or so and be specific on a little bit more specific on a couple of tools, and then show how do we kind of do a little bit of RTFM specifically for Azure, where are the kind of authoritative sources there, and then we're going to wrap it up with some takeaways from kind of broader tactics for both blue and red teamers alike. So very, very briefly, just 4 different layers. There's infrastructure level, and platform level, application level, and runtime level, where we can enforce its security. So it's always the onion model, the layered model is always somehow there. But basically, depends again which level are you working with. You have different tools available. Some of these you need to work kind of in conjunction with the others. We are mostly here now looking at this platform level here, because this is where, whether you are just doing kind of cloud native kind of container stuff and you are using like Kubernetes stuff, or you are doing more platform as a service oriented stuff, or a mix and match of everything. If you are using cloud provider tools like policies, this is where you can actually enforce and have like a single throat to choke in most cases. And then if you're using some of the Kubernetes stuff, then also you have a concept of policies that you can implement with stuff like admission controls and similar techniques and tooling as well. All right. Very briefly, this is kind of shifting left the most. This is just a quick screenshot. I'll just explain what's there. This is just VS Code. What I have in here is basically just Jacob. It's an infrastructure as code security linter. Basically, they branded that as SAST. You can run this into your CI/CD, of course. Here I'm doing, of course, stupid stuff. There's an old version of like Ubuntu that I'm spinning up, and in Terraform, it's not even doing SSH authentication, let alone any centralized identity of the cloud provider. So clearly something that I should be alerted on. I'm getting a tooltip from Chekhov as a developer to kind of just to let me know that there's like 3 different rules that I'm breaking in this case. If you don't do anything else, just letting them add yet another extension to their tool chain. Doesn't have to be even specific to your stack. You can add your custom rules, of course, but removing a lot of that stuff from being found out only at the deployment or PR level and bringing that earlier is a great productivity boost for us as security folks. Yeah, so this was on Chekhov's side, but mainly an example on the infrastructure as code, security scanners. There's different terminologies. Sometimes they call it SAST, but these are security linters for what they're worth. Then on that Kubernetes side, there's different types of policy engines that effectively just implement the kind of generic Kubernetes admission controller, which is similar to the cloud providers. Basically, you have for each set of control planes, you have a set of approved actions and approved behaviors that on the cloud provider side you implement as service policies or GCP org policies or Azure policies. On the Kubernetes side, you first need to install some sort of an admissions controller or policy engine first, and then you need to load that up with or implement your policies on that level. So here I have, this is just a bunch of YAML. This is a service, or this is just a deployment of a set of Kyverno policies. Kyverno is one of those CNCF tools that implements the admission controller policy engine. You can get a nice list of basically pre-made kind of CIS top list of hardening stuff that you can just easily deploy into your cluster. It's quite non-intrusive. Depends on how your cluster is hardened from a kind of access control perspective, if the users can turn it off or not. But basically, just to create this kind of paved road, happy path. This is a Helm chart. Just download Kyverno, and they have their own library that even in that Helm chart, you can just say, use this ready-made template there. Here's one of those examples, which is requiring approved base images. So again, just a short note for recap. Container images are always based on some other images. They are almost like virtual machine images, but not exactly. But basically, they introduce some other exposure space for us. it's very easy as a dev to just make a quick typo. There's an example of NPM-focused attacks where basically there's in Docker Hub publicly available some base images that basically just they're just typo squat, basically. They look like they are legitimate NPMs images or small micro distributions that have the minimal configuration needed for running NPM, but in fact they are of course building on something else. So if you have kind of a classic kind of golden image standard requirement, this is one of those requirements that you will implement, but basically it's just a policy engine. You have all of the similar kind of taxonomy, similar kind of evaluation language that you have for other stuff. You can deny, you can just audit. That's really it. And there's a good baseline available from in their Helm chart as well, so that you can just do a baseline good audit set, and you're good with that. So kind of moving from that deeper level on the Kubernetes side to kind of bringing the same concept into the cloud space. I mentioned Azure policies, AWS service policies, GCP org policies, these policies before. Here we are. If you've used Azure, you've seen this likely before. There's various different levels of hierarchy, just like you deploy hierarchy for these policies or for your users or for your permissions. Similar hierarchies apply also for policies. These are cumulative, so even if you have owner access, if there is something that prevents you from doing in that space that's against that policy, the policy overrules that. So exactly the same behavior as those admission controllers and those Kubernetes policies as well. This is just the same example that I keep on kind of the easiest possible misconfiguration that we have, which is again, if I'm deploying or if I'm doing anything, in fact, deploying, changing for storage accounts, there has to be and if I am adding this allowed shared key access, which is the legacy authentication, you don't even need a connection string. It's just one piece of token, and you can do anything with it: read, write, update, delete. You have all the permissions, and you have none of the auditability there. Again, here we are just checking the same checkbox that we saw on the screenshot earlier, just on the policy side. If that's true, then deny. Easy peasy. You can deploy this. Just a quick update on the Azure policy hierarchy side, which is the same for other policies as well. Even if it's on deny mode, you can deploy this in an existing environment, which makes it so that the future changes or future deployments are not going through. So at least you're keeping that existing state that you have. And then it acts as an audit mode. The policy evaluation engine anyway does the audit for existing stuff, so it doesn't break those, it doesn't change those, but it gives you a neat little list that you can then follow and harass the teams to get them fixing those. And that's a quick segue into the Azure side there. So we have the tools, we have policies, we have ways of implementing these in infrastructure as code. We now know how do we go about enforcing that these misconfigurations are not happening, or at least they are not happening, it's not spreading anymore. We need to RDFM. So just specifically on Azure side, there is something called Microsoft Cloud Security Benchmark, formerly Azure Security Benchmark, but it's also multi-cloud nowadays. So it falls into this neat little origami that the policy team has put together. But basically, it gives you this kind of enters into this traditional problem space of we have an Excel list of various different security controls that are all about actually doing the same technical thing, but different frameworks have a different name for it, and they may have a different taxonomy, different set of Excels for that. So instead of running that same Excel 10 different times, what MCSB is doing is that they have a vendor-provided list, so Microsoft officially provided list of these controls, saying that for these 4 different controls, so CIS critical controls 8 and 7.1, as well as PCI DSS and and NIST controls. These are the generic ones that can then map into pretty much anything else as well. But you don't need to prove someone that this is how we analyze, this is how we translated these controls. This kind of Microsoft official list that's been approved by each of those 3 vendors as well. That you can say that when we implement this technical thing, it's going to tick the boxes in these and these boxes in these and these control frameworks. And that's then the language that your audit department can then work with. There's a bunch of different categories there, from network to DevSecOps security. Basically, this is if you just enable a new Azure service, you're going to get, and you enable Defender for Cloud, you're going to basically get these deployed to some extent. So there's like 200 different Azure policies that get deployed or that are part of that policy initiative. Not all of them are actually enabled, but they are part of that initiative. You can manually go ahead and turn those on to get more compliance. But then there's a bunch of stuff that is part of this documentation, part of these requirements, but there's no built-in tooling for you, and that's the gap that you need to fix yourself. So just as an example, if you're looking at, and this is the AI slide, a slide in here just so that we can all say that we did something AI today. This is for, is this now Foundry or Azure Foundry? I can't keep up with all of the branding changes, but the tool formerly known as Azure OpenAI Service. And why it's Azure AI Services as an overall category is that the resource provider is Microsoft.cog services. So that's where we have this common taxonomy there. But basically, there are 4 policies available in this Microsoft Cloud Security Benchmark, which is not a lot. There's only four built-in policies that we can use to secure our new fancy shiny object, and we had quite a bit of requirements in that large list of things. Again, 4 policies built in. Actually, at Datawork, there's 35 different requirements in the actual baseline. So the Excel sheets, the documentation work, the audit work, that's 35 different things. 4 of those things are available for us out of the box. 7 of these things, so the stuff that's in here, these are then actually something that we need to actually do or can do something about ourselves. So some of these are about enabling new services, some of these are about deploying those 4 policies, and some of these are just configuring things differently, introducing some new services here as well. Stuff like put your stuff to a key vault, put a network DLP feature or DLP feature in place, which is just a firewall for this service. So huge list of stuff in the Azure Cloud Security benchmark, which is for everyone. Baseline is 35 different things for each cloud service, and then there's your mileage may vary type of effect for each of those services, how much is actually done for you. In this case, 7 out of 35, so quite a lot of stuff left out for us to do. And building that automation, selecting what do we really need to be doing in here, building that automation into infrastructure as code, making sure that gets deployed securely, making sure that we have a policy that then measures that are we still doing the thing that we are supposed to be doing on that infrastructure as code, and then hopefully feeding that all into some sort of a security SecOps monitoring process as well. Then that's kind of the whole loop of doing it the hard way when it comes to managing those misconfigurations. Here's just one last example on the infrastructure as code side. We have just an Azure Key Vault that needs to meet this kind of fictional air quotes requirement of the Key Vault should have a firewall enabled. We talked about this public access before. Key Vault is a different resource because it's always behind the Entra ID anyway nowadays. So you could argue that always is behind some sort of a firewall because conditional access. But we can and should add an actual firewall set of rules in there as well. That's specifically how we do that on Terraform. We have a complementary or a similar Azure policy that we can then use to monitor that as well. And that kind of brings that from that shifting left from pre-deployment. We run this through all of our infrastructure as code SaaS. We get all of that linting done. It's built securely. We deploy it, and then we deploy our policy to make sure that it's kept intact. Okay, so time to start wrapping this up with some tools and tactics and a bit of homework for everyone. So a bit of tools first. We talked about some of this stuff before. Depends on which infrastructure as code tools that you're using. If you're doing Terraform, just easy thing is just to install tfsec as part of your deployment pipeline. Just put it in audit mode. That already gives you some visibility there if you're not doing that yet. Terscan, tfsec, whichever. You can do Chekhov. You can do any of these vendor of your choice, GitHub Enterprise, Azure DevOps, whatever tools we may have. That's for infrastructure as code. That's before we deploy anything there. There are a few tools also for YAML because, again, humans shouldn't be reading YAML, but that's what we end up doing. So we need some sort of security for the YAML files as well. So there's stuff like kubesec, there's Polaris, there's a few others that you can do there. And then you should do all of your kind of secure Git ops there so that you actually would break the build if you find certain level of security misconfigurations in there as well. Once we get that from deployment, we actually deploy it, and we want to have some sort of runtime security in there. There's some commercial tooling in there. Everyone loves to talk about the $30 billion company, which is no longer seems hyper-inflated anymore compared to all of our AI stuff. This is, of course, kind of the brainchild of this branding for CNAP. We used to talk about we have multiple different brands in there, but this kind of cloud-native application protection was a good kind of term that they coined in there. You can also go if you have this kind of shiny object syndrome on your own premises. Maybe you already have your budget on Prisma. Maybe you also have, or Cortex, I think the Palo Alto now calls the entire suite. Depends on your tool set there. Just use a CNAP. If it's built into your cloud, that's great. If you already have licenses for it for a third party, that's also great. Just use a CNAP. That's basically it. If you're doing containers, CNAP is not enough, whatever those vendors say. Have something specific for your Kubernetes stuff. Falco is one of those tools that is great for Kubernetes runtime security. It's running on ePBF, so it's on the kernel level, actually reacting to those events. So that's kind of your lowest source in there. And if you're doing some active analysis on or some scanning of your own in addition to these tools, you can use stuff like CloudSploit, Scout Suite, some of these others to do some light scanning of your environments. And then to keep that consistent state on security side, we talk about Kubernetes, we talk about these cloud provider specific policies. Of course, if you are into Terraform, if you are into that kind of broader stack of the paid set of features from Hashi, you can do Sentinel policies. Each of these are great. Just use these consistently, and you're good on that side. So a bit of homework as promised. Depends on your role. So for red teamers, basically what I like all of us to be doing is to scan for those public storage accounts. We think they are not there, but they're always there. And specifically, whether or not they are public, just look for those legacy authentication methods as well. Look for those connection string or this non-centralized identity connections, especially now on the AWS side, now that we actually have that tooling for workload identities. This is the time to kind of start that migration and build the muscle to get away from those. And then again, if you have any Kubernetes environments, dashboard shouldn't be there. Dashboard isn't even there by default anymore, but you can still go ahead and install that dashboard. And if you are a dev in need, you still may end up doing that. So just some quick call-outs for on the red teamer side. On the blue teamer side, just one policy, please. Just one manual policy that you can pick the easiest or kind of the most absurd. It feels like no one is going to do this. But again, just about building that muscle. Deploy a policy as high level as possible to get broad coverage. Do it in audit mode only, and you'll be surprised. You'll be surprised. If you are running those Kubernetes environments, then I do recommend that you install Falco. Just like you could go ahead and install Kubernetes as well. That's a little bit more work for your policy side. Falco is basically you just turn it on and you wait for panicky alerts. If you're using Azure, there's a new-ish set of logs that most folks don't know because it's very neatly worded or neatly branded. There's something called graph activity logs. So the graph activity logs are actually about all sort of tenant level monitoring against the Microsoft Graph API, which again covers your workload identities, it covers your application identities, it covers your user identities. And that's kind of a view that we never really had before. We had separately, we had Entra ID, we had Azure, we had SharePoint, we had other kind of individual sources, but nowadays under the hood everything goes through Graph, but we never had a Graph audit log source available for us. But Graph activity logs is the name of the log source that you are looking for and then that you should be enabling there. And yeah, just a reminder to do an audit of your service principals there. Just a manual one, don't even have to be a tool like Kim or anything. I can guarantee you there's so many of them that are unused in there. And lastly, for everyone, just some kind of good discussion pointers when you are kind of don't have anything to talk about with your family, I guess. At least this is what I talk with my family, so I don't know if it's good or bad. Yeah, do check this from a networking perspective. It's not just enough that you have a service deployed called firewall or resource firewall. Do actually check what you are doing in there. If you are dealing with a resource level or service that has a resource level log available to it, make sure that you actually check where are you sending those logs and is that location public, because most of the times it is. Scan those container images specifically for those manual secrets in there. If you have just any sort of linter for your Docker files, you're pretty much good to go already by that. It is quite easy for us to do that. And then again, when you get home tomorrow or very get to the office tomorrow, rotate just one set of creds for me, please. And then we're good to go. Just quick TLDR, misconfigurations have been, used to be, and still are the worst possible offender out there. And again, it's not just the fact that we did something wrong. Most of the times it's the fact that we didn't do anything. Either the service is misconfigured by default, and it should be from the shared kind of security model perspective, it should be the provider who keeps a good baseline out there, but it's our responsibility in reality to make sure that it's configured properly for us and it's put together properly with other tooling there as well. Stop hugging your servers. They are in the cloud already. Pet projects aside, but really the mindset is very different. You really need to have cloud overusing cloud native here, but you need to have cloud first solutions to cloud first problems there. And again, those security defaults are not secure. And everything as code, specifically policy as code, but if you can also infrastructure as code, I would love that. And that's really it. I did have apparently a hidden slide. Just very briefly, I did bash AI quite a bit, but I did my research on that, so I do have a new-ish Azure OpenAI security book out. It's AI and it's a physical book, so obviously there's lots of things that have changed since then. But I do recommend you check it out from your local library or O'Reilly Safari or wherever you get your physical or digital books. I also have a few courses on LinkedIn Learning. If you don't have LinkedIn Learning, just ping me after this in LinkedIn, and I can send you a free unlock for any of those courses. This particular one that's linked in here is related to this topic of managing these misconfigurations out there. And yeah, thank you once again. Thank you so much for having me here. I think we do have 5 minutes for questions, so if you have any, happy to take some on. It's a little bit hard for me to see if you're out there on the back because of the light, but holla if I don't see your question there, and I'll be around as well. So happy to take some either now at the stage or later. All right, if you're being shy today, then thanks again, and have a fun rest of the conference. I think one more session to go, right?